Hello students, how are you? I hope you are doing good. How are you all, JNV Anna? So I welcome you all in this session of wave optics. Yesterday we have finished with geometrical optics. Now it's turn for wave optics. Got it? So make sure the screen is visible to you and audible to you. If the screen is visible, let me know in the chat box. Yes and no. GNV NM student. Okay. Let me start with the wave optics. So in this chapter, we are going to understand about Huygens theory in this class only. And in the next session, we will be doing interference and diffraction polarization. Okay. So in today's lecture, basically we focused on the Huygens theory. Okay. Hello, Christina. How are you? Make sure the screen is visible to you and I'm audible to you. Okay. So if I took you to the history of development of optics, so we'll start with 1637. So in the 1637, Descartes, there is a name of physicist or you can say mathematician also. So they have developed the corpuscular theory of light or corpuscular model of light. According to this model, like in the geometrical optics, mostly we have discussed this model only. Okay. In which we assume the light made up of small particles. Okay. So this is nothing but the corpuscular theory. So according to that, these small tiny particles named as corpuscles, these strike to the surface and reflect back according to the collision happening and momentum conservation. Okay. So these two principles they have used here. This Descartes has used to elaborate all the laws, and he is the responsible for driving the Snell's law. So here incident ray, you can see this incident ray is made up of small corpuscles, which is very tiny particles. And after the collision from the surface, which is nothing but the reflecting surface, these corpuscles moves in the opposite direction of it. These are called as reflected corpuscles, and these are called as incident corpuscles. Now, after that, he successfully derived the Snell's law and explained this law with this theory. But as we know that if there is some theory and that is not properly developed, we can have what some drawback of this theory. But following the Descartes in 1672, Isaac Newton, sir, I think all of you are very much aware about this name. They have developed this corpuscular theory only, which means they also believe that light is made up of tiny small particles. And based on his laws of momentum and conservation of energies, he developed this book, which is Optics. or a treatise of the reflections, refractions, inflections, and colors of light. He successfully explained the formation of image into our eyes on the retina with the help of this corpuscular model only, and the variation of colors and the spectrum in the prism. All phenomena Newton sir has explained using this corpuscular model of light. But when the other phenomena are observed, other phenomena is what I mean by other phenomena. Hello Praveen, how are you? Acha, no one is responding in the chat box about the screen is visible and audible. How would I know कि you are getting it or not? It's very sad. Okay. Then after Isaac Newton, sir, Christian Eugene Huygens came into the picture. And why? Because there are some phenomena. Good afternoon, Praveen. Okay. Corpuscular model of light is explaining all the laws like law of reflection, law of refraction, why the spectrum of light prism in the prism is we are getting. But when we talk about this interference, when we talk about the interference of light, diffraction of light. So these phenomena cannot be explained using corpuscular model of light. Okay. So corpuscular model of light will not has not explained interference and diffraction and some other phenomena also. Although there is one belief that Newton has developed that whenever the light will move from rarer medium to denser medium, its speed increases. Okay, and it's a clear observation because of the corpuscular model of light. But as we move further, there is a very renowned scientist, which is or physicist, we can say Christian Huygens. They have given the wave theory of light. Like in the initial years, it just 6 year gap. So Newton was a big name. In spite of that, Huygens was not at that big at that time. So this wave theory didn't get so much of acceptance at that time, which means nobody want to believe that the light is a kind of wave. They all believe that it's satisfying the corpuscular model of light, which is light is made up of very tiny, tiny particles. Hmm? Then in 1801, when Thomas Young, which is also a great physicist in his field, has developed some experiment, and that experiment can be only explained if you assume that the light is a wave. And at that time, you will get, at that time, we have got the acceptance, worldwide acceptance of wave theory of light. Okay. And that experiment is interference experiment. We are also going to describe that. Now, what is the failures of Newton law? First failure is that Newton assumed that light travels faster in denser medium than in rarer medium. which has been proven wrong, बिकॉज लाइट की सबसे ज्यादा स्पीड तो वैक्यूम में ही होती है. देर इज नदर नो अदर मीडियम प्रेजेंट. And corpuscular theory cannot explain the phenomena of diffraction, interference, and polarization of light. I have explained it previously. Now, this is the according to geometrical optics, light will travel in the straight line. But this thing also has a concept behind it. If the object which is coming in the way of light is very large in size as compared to the wavelength of light, then it will seem that light is moving in a straight line. But if the object which is coming in the way of light is of order of the wavelength of light, then the straight line nature of the light will change. ठीक है. So wavelength of visible light is very less than the dimension of typical mirrors and lenses that we use. ठीक है. So that light can be assumed as approximately travels in straight line. ठीक है. So that is why this phenomena is already here given here. If you use this device directly, you are able to see this. ठीक है. But if you bend this at that same time and you have placed a mirror here or a lens here, what you will see? Would you able to see the image of this? Would you able to see the light? Somehow, then why it is happening? Because it is bent. So if light is traveling in straight line, it should not cross this and you goes to our eyes. But it usually happens. At least we know that there is something is lit in front of the object that we are using. Okay. So it's because of wave optics or wave nature of light. Size of obstacle in the path of light is in order of wavelength of light. If okay, then we can say light does not travel in a straight line. Kab? When the size of obstacle in the path of light is in order of wavelength of light. अगर वेवलेंथ आप 400 न्यूटन मीटर ले रहे हो तो जो ऑब्स्टेकल आप यहाँ पे प्लेस कर रहे हो दैट वुड बी 450 न्यूटन मीटर और 500 न्यूटन मीटर or 1000 newton meter like this. Okay. Then what you will see that light is not traveling in a straight line, and that is wave optics. Now what does Huygens theory says? We have to study wave front in this, then Huygens principle, then the reflection and refraction according to Huygens theory, and the Doppler effect. अब देखो firstly we have conducted an experiment which is nothing but Young's double slit experiment. इस तरह का कोई सेटअप होता है उसका. ये स्क्रीन है. यहाँ पे मेरा पॉइंट सोर्स है. तो यहाँ से लाइट आई एंड वी नो दैट लाइट अगर एक पार्टिकल होता, इफ लाइट इज ओनली मेड अप ऑफ पार्टिकल्स, तो आप अगर पार्टिकल ही मानोगे तो लाइट को केवल इस पार्ट में ही दिखना चाहिए था, एटलीस्ट इतना पार्ट बस, या फिर इतना पार्ट. बट वी आर सीइंग दैट मैक्सिमम पोर्शन that we are seeing is in the mid, then how it is possible? ठीक है. So that is why this corpuscular model of light is not able to explain, was not able to explain this phenomena of interference. Got it? Now, wave front. What is wave front? And that is the tool that we need to understand the Huygens principle. देखो ये हमारे पास टैप है और ये नीचे पूरा वाटर है, कोई भी लिक्विड सरफेस है। अब देखना अब क्या होता है। When the drop downs, these types of ripples form in the, these ripples will be formed whenever you disturb the water or you drop the coin or what. It's like this drop coming down and you will see this disturbance. Okay, these ripples, although nobody is moving further, they are oscillating like this, up and down, up and down. This one you can see here, this is only moving up and down, and that is why this ripple is being formed like this. But if you see that this particle, this point of particle, ये particle कहीं move नहीं किया, ठीक है, वो पार्टिकल वही है, बट वो क्या कर रहा है, ऊपर नीचे ऑसिलेट कर रहा है। क्लियर? सो दिस इज कॉल्ड एज वेव फ्रंट। क्या होता है वेव फ्रंट? लोकस ऑफ पॉइंट्स विच ऑसिलेट इन द सेम फेज इज कॉल्ड वेव फ्रंट। तो इस एग्जांपल में ये जो पार्टिकल है जिससे ये रिपल बना, ये ऊपर नीचे की तरफ जा रहे हैं, ये सारे पार्टिकल मिलके क्या बना रहे हैं, सर्कल बना रहे हैं। यहाँ पे बड़ा सर्कल बन रहा है। So these types of circle is nothing but representing the locus of those point was in the same phase। ठीक है, एक साथ जो ऊपर जा रहे हैं, एक साथ जो नीचे आ रहे हैं, उन सभी पॉइंट्स को कनेक्ट करोगे, देन यू विल फाइंड अ लोकस। लोकस इज नथिंग बट द path, and that path or that curvature is termed as wave front। So if you will see in the previous section, the circular wave front is being obtained in this part। ठीक है, so light ray is also a wave, so it also forms some wave front। तो वेव फ्रंट की क्या चलेगी, लाइट रे हमेशा परपेंडिकुलर डायरेक्शन में चलेगी। लाइक एज यू कैन सी, मोशन किस तरफ हो रहा है, मोशन इज हैपनिंग रेडियली आउटवर्ड। देखो यहाँ पे दिख भी रहा है पार्टिकल किस तरह से जा रहे हैं। तो ये सारे पार्टिकल क्या हैं, परपेंडिकुलर ही तो हैं इस वेव फ्रंट के। ठीक है, तो अगर लाइट भी वेव है, जो कि है, तो light rays always travel in perpendicular direction to the plane of wavefront। ठीक है, and whatever the waves, it always travel perpendicular to the wavefront। ठीक है, so this is the path of travel of wave, this straight line। and what is this circle? Circle is the wavefront, ठीक है, of points which are in same phase। ठीक है, the speed with which the wavefront moves outward फ्रॉम द सोर्स इज कॉल्ड द स्पीड ऑफ द वेव। तो जिस स्पीड से वेव बाहर की तरफ जा रही है, उसी स्पीड से वेव फ्रंट भी हमारा आगे की तरफ चलेगा। ठीक है, लाइक दिस। नाउ स्पेरिकल वेव फ्रंट। तो अगर मेरे पास कोई पॉइंट सोर्स है जिससे सभी डायरेक्शन में लाइट रेज आ रही है, उन लाइट रेज के परपेंडिकुलर वेव फ्रंट होगा। क्यों? क्योंकि वेव फ्रंट के परपेंडिकुलर अगर लाइट वेव है, तो लाइट वेव के परपेंडिकुलर वेव फ्रंट डेवलप होगा। So if a point source emits wave uniformly in all directions, then the locus of point which have the same amplitude and vibrate in the same phase are spheres। So these wave fronts are known as spherical wave front। कहने का मतलब सिर्फ ये मेरे पास एक पॉइंट सोर्स है, यहां से जो लाइट होगी वो हर डायरेक्शन में जाएगी, ईच एंड एवरी डायरेक्शन। तो इस पॉइंट ऑफ टाइम पे, लेट्स से इस पॉइंट ऑफ टाइम पे और इस लेंथ पे, ये पार्टिकल यहाँ है, ये पार्टिकल यहाँ होगा, सेम पार्टिकल्स, they are oscillating। if you connect these particle, what you will find out, you will find a circle। If you connect the other particle, you get another circle but bigger radius. ठीक है? So that is why this wave front is the locus of those points which are in same phase. और ऐसा ही यहाँ पे भी same amplitude and vibrate in the same phase are spheres, and those wave fronts are called as spherical wave fronts. So always remember, from a point source, always spherical wave front will be formed. Now this medium is homogeneous and isotropic, which means all the properties are same in all directions. There is no movement. देखो ये पॉइंट सोर्स है, इससे लाइट जनरेट हो रही है. अब ये लाइट आड़ी तिरछी क्यों बनाई है? क्योंकि इट इज showing us a wave. But if you will connect all those points, you will find that there is a spherical wave front here. ठीक है? Got it? So small portion of the sphere can be considered as plane. So these wave fronts are known as spherical, or sorry, plane wave front. देखो प्लेन वेव फ्रंट कैसे बनेगा. अगर आप जूम इन करो स्फेरिकल वेव फ्रंट में, और एक बहुत ही स्मॉल पोर्शन आप कंसिडर करो, बहुत छोटा पार्ट, तो यू विल फाइंड दैट दोज आर नथिंग बट प्लेन्स, that will be behaving as a plane. बिकॉज सर्कल का एक छोटा पार्ट क्या होगा, अगर मैं यहाँ पे सर्कुलर आर्क डिजाइन करता हूँ, तो दिस पार्ट you can consider as plane. So we can say that a spherical wavefront is a combination of infinite plane wavefront. ठीक है? So इससे ये भी पता चलता है कि देर इज अ पॉसिबिलिटी ऑफ प्लेन वेव फ्रंट्स ऑल्सो. अभी देखेंगे हम कितने तरह के वेव फ्रंट है. फर्स्टली, व्हाट इज हाइगेन प्रिंसिपल. अब हाइगेन ने बस थोड़ा मैथमेटिक्स लगाया. क्या कहा उसने? इफ वी नो द शेप ऑफ द वेव फ्रंट एट t is equals to 0, then Huygens principle allow us to determine the shape of wavefront at a time later. और कैसे? भाई जैसा पहले बना रहा है, अगर मुझे पहले पता है कैसे, और वेव मेरी यूनिफॉर्म वे से आगे बढ़ रही है, तो मुझे अगला भी पता चल जाएगा ना, कि भाई ये जो पार्टिकल था, ठीक है, टी इज इक्वल टू 0 पे कहाँ है? यहाँ पे है. बट एट टाइम t इज इक्वल टू टी, इफ दिस पार्टिकल इज मूविंग विद स्पीड v, तो ये डिस्प्लेस कितना होगा? vt. और इस पॉइंट पर जितने भी पार्टिकल्स होंगे इस पैथ पर, वो सब के सब कितना डिस्प्लेस हो जाएंगे? vt. इफ यू कनेक्ट दोज यू विल गेट अ वेव फ्रंट. दैट इज द सिंपल प्रिंसिपल ऑफ हाइगेन्स. इफ यू नो व्हाट इज द वेव फ्रंट अर्लियर, you can get the value of wave front what is after. Okay, Harish, I'm explaining in English. The wait for the moment. Huh? So if we know the shape of the wavefront at t is equals to 0, then Huygens principle allow us to determine the shape of wavefront at a later time. Which means at t is equals to 0, if you know that what kind of wavefront you are having a spherical wavefront or a plane wavefront. So after t is equals to, let's say somehow, sometime later, you can predict that what kind of wavefront you are getting. Okay, that is simple Huygens principle. Now it involves some mathematics also. So each point on a wavefront acts as a fresh source of disturbance of light. How? Yeah. If we have a spherical wavefront like this, so this spherical wavefront contains enormous amount of points. It can be made up of infinite points. Okay. Now each point will act as a point source, and that will develop its own spherical wavefront. This point will also develop its spherical wavefront. Each and every point will develop its own spherical wavefronts. Okay. So this is the first point, that each point on the wavefront act as a fresh source of disturbance of light. Got it? The second thing is, the new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelet at that time. मतलब अभी समझते हैं, देखो ये हमारे पास वी हैव अ सोर्स एस। अब यहां से दिस इज द लाइट रेज, ठीक है, दीज आर द लाइट रेज, पॉइंट सोर्स है तो दे विल बी रेडियल इन एवरी डायरेक्शन, बट वी आर कंसिडरिंग दी ओनली फॉरवर्ड. So if you join this point, and this point, you will get a spherical wavefront. Okay. But this wavefront test is equals to zero. Now, these points, we can assume that this wavefront is made up of number of points. And that point will also behave like a wavefront. Sorry. These points will also behave like a point source, and they will develop their own wavefront in the forward direction. Now, at t is equals to tau second, which means some time earlier, this point has been shifted with v tau because the velocity of the light is, we are assuming here v. So in tau second, it will be shifted v tau. Okay. And each individual particle will have shifted with a distance of v tau, isn't it? If you draw the tangent to the forward section of it, this is the forward section. If you draw the tangent, then you will get the new wavefront at t is equals to tau. And we are getting this wavefront because of the previous wavefront at t is equals to 0. Now, there is another wavefront also that you can draw using this. This is called as backward wavefront. Backward wavefront. Okay. This is the new wavefront spherical. अगर हमारे पास एक प्लेन वेव फ्रंट है तो उसके भी डिफरेंट पॉइंट कंसिडर करेंगे, दैट पॉइंट विल बिहेव लाइक अ पॉइंट सोर्स, और जो ये फॉरवर्ड साइड है इनको ज्वाइन करेंगे आप, देन यू विल गेट अ न्यू वेव फ्रंट एंड दैट वुड बी प्लेन. सो बैकवर्ड वेव फ्रंट को हम रिजेक्ट कर देते हैं, इसलिए वेव थ्योरी ज्यादा चली गई. ठीक है. नाउ रिफ्रैक्शन एंड रिफ्लेक्शन बाय हाइगेन प्रिंसिपल, आई थिंक सबको क्लियर है बैक ये वेव फ्रंट कैसे फॉर्म होता है. So the new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelet. Forward envelope लेना है, all the secondary wavelet at that time. So this is the forward envelope. This one, this part. Okay. So when we connect them, we'll get a new wavefront. Similar to the case of plane wave. Now refraction and reflection. Firstly, we'll discuss about the refraction of light, explaining not with the corpuscular theory of light, not with the ray optics. We will get this explanation with Huygens principle. This is the rarer medium, the upper one, and this is the denser medium. In rarer medium, the velocity of the wave is v1 and the refractive index is n1. In denser medium, velocity of wave is v2 and then refractive index is n. Now, these are the incoming rays, and we know that each ray will bend toward the normal because n2 is denser, n1 is rare. Got it? Now these wave can develop. अब देखो इन वेव का किस तरह का वेव फ्रंट होगा. These are parallel to each other. So if you draw the wave front like this, each point will behave as a point source. If you draw the envelope here, first envelope को copy करेंगे, so you will have a plane wave front. ठीक है. and that plane wavefront which is AB we have drawn here, which is at 90 degree angle of each of the wave. कहीं से भी आप मेजर करें. Got it? Now अब ये क्या हुआ, बेंड किया. इस पॉइंट्स का जो वेव फ्रंट होगा कैसे होगा, ऐसे होगा. तो इसे ही ज्वाइन करूंगा तो सर्कल मिलेगा. ठीक है. दिस विल बी एक्टिंग एज अ पॉइंट सोर्स फ्रॉम हियर, और पॉइंट सोर्स से ऐसे ऐसे वेव फ्रंट आ रहे होंगे. ठीक है ना. नाउ यू कनेक्ट दिस ऑल्सो. ये इस पॉइंट का फॉरवर्ड एनवेलप है. ऐसे ही इस पॉइंट का एक फॉरवर्ड एनवेलप बनेगा. ऐसे ही इस पॉइंट का बनेगा. इन्हें तीनों को ज्वाइन किया तो फिर से मुझे क्या मिला, प्लेन वेव फ्रंट मिला. ठीक है. ये दोनों नॉर्मल है एट द पॉइंट ए एंड पॉइंट सी. दिस इज नथिंग बट अ बीम ऑफ लाइट इज कम. नाउ if this angle is I, which is angle of incidence, this angle will also be I. How? Echo. If this is I and this is 90, so definitely this angle will be 90. So this angle will become 90 minus I, and since this is also 90, so this will become I. Here you can see. If this angle is what? This is I, this is 90 minus I. This angle will become 90 minus I, so this angle will become I. Clear? Similarly for R, this is R bending towards the normal. This is the refractive angle. So this angle will also become R. Similar explanation you can give here also. Got it? These are perpendicular. If this is 90, so this angle would be become what? 90 minus R. This angle will become R. Now, here AB is nothing but incident wavefront. CD is nothing but refracted wavefront. And XY is nothing but the refracting surface. Okay. Now, BC we know, this one BC is V1t if the velocity of this wave is V1 in this medium. So BC, that distance it would cover is V1 into tau. Let's say the time taken from here to here is tau. Now AE, which is the distance traveled by this wave front in second medium, and in second medium the velocity is V2 and time taken is tau. So that is why distance cover AE is V2 into tau. Now from triangle ABC, this triangle, this is a right angle triangle at B. Sin I, if you will apply, sin I will become what? Perpendicular, which is BC, upon hypotenuse, which is nothing but AC. So BC upon AC will become V1 tau. We can put the value of BC as V1 tau divided by AC. Now from triangle AEC, same is the right angle triangle. If you apply sin R here, you will be getting AE, which is perpendicular. देखो इस एंगल से मेजर कर रहे हैं तो this would be perpendicular, and CE will be the base. ठीक है. Again, AC will be the base. You can take here like this. Okay. AC will be the hypotenuse of triangle AEC. Now, from equation 1 and 2, you can equate the value of AC. So you will get that sin I upon sin R is equals to V1 upon V2. And we know that V1 is directly proportional to 1 by N2. V is nothing but C by lambda. This you should remember. And lambda is nothing but, in Cauchy's relation, we have seen that 1 upon lambda is nothing but mu or n. These are the refractive index. Now, V is equals to C by n, you can say. C by n is C by n. यानी कि C by mu. So n1 sin I is equals to n2 sin R, and this is nothing but the Snell's. What we have did? We have draw a plane wavefront of AB and plane wave refracted wavefront EC. Then we have made two triangles ABC and AEC, and from that sin I and sin R we have applied. So we got this results. Okay. From equation 1, you can write like AC is equals to V1 tau upon sin I, na? And from equation 2, similarly, you can write AC is equals to V2 tau upon sin R. So when you equate them, this will become V1 tau by sin I, V2 tau by sin R, tau and tau will cancel out. So we'll get here sin I by sin R is equals to V1 by V2. Okay. So this is how we have proved the refraction of light with the help of Huygens principles. And Huygens principle represents what? Wave theory of light, which means by assuming the light as a wave, we can explain the phenomena of refraction. Okay. Lambda 1 and lambda 2 represent the wavelength of light in medium 1 and medium. So similarly, we can relate the lambda and V also. Got it? And frequency is equals to nu upon lambda, V upon lambda. This is velocity of light, or wave, you can say specifically wave. Got it? Now reflection of light. Suppose this is the XY surface, reflecting surface we have considered. Now again there is a plane wave front is coming out. अगर ये लाइन पैरेलल है ना, इफ द रेज आर पैरेलल, तो इनका जो वेव फ्रंट बनेगा दैट विल बी प्लेन लाइक दिस. क्लियर? देखो, this is the AB, the wave front of incident wave, and again CE is the wave front of reflected rays. Reflected this time I'm using. Now two normals. If this angle is I, again this angle definitely be I. Okay. If this is R, this angle would be R. Clear हुआ? This is the law of geometries. AB again is the incident wavefront. CD again is the, and this is not CD, CE you can consider in previous case also. So BC is equals to V tau. BC is what the distance covered by this incident wavefront in tau time, and the velocity will be remaining same because it is reflecting in the same medium. So V tau. Similarly, AE will equals to what? This AE will equals to BC because it is also equals to V tau. Now we can say that triangle EAC and triangle BAC are congruent. So angle I should be equals to angle R. This is the law of reflection. Okay. So laws of reflection and refraction is same as in ray optics. So the behavior of prisms, lenses and mirror will be same as in ray optics. ठीक है? देखो, ये कनकेव मिरर है. Incoming rays are parallel. After reflection, it will focus the rays on the principal axis. तो इसका वेव फ्रंट कैसे बनेगा? देखो, इंसिडेंट वेव फ्रंट तो क्या है? AB, which is plane. लेकिन आफ्टर रिफ्लेक्शन इट इज कन्वर्जिंग. तो इट इज सीम्स लाइक कि यहाँ से इस पॉइंट सोर्स से लाइट रे आ रही है, तो पॉइंट सोर्स से कैसा वेव फ्रंट बनता है? स्फेरिकल. सो दैट्स हाउ वी ड्रॉन इट. नाउ AB is the incident wave front, CD is the reflected wave front. For convex mirror, देखो ये उल्टा चला गया। So if we extend these two lines, it appears to move at here. So जो reflected wave front बनेगा वो कैसे बनेगा, ऐसा बनेगा। It seems like it is a point source and point source से rays आ रही है, wave आ रही है, तो it will be a spherical wave front। ठीक है। सिमिलरली लेंस से अगर बात करें तो कन्वेक्स लेंस कन्वर्ज करता है रेज को। पैरेलल अगर रेज है तो प्लेन ही वेव फ्रंट बनेगा। अब देखो ये कन्वर्ज हो रही है, इट सीम्स लाइक दे आर कमिंग फ्रॉम दिस पॉइंट, they are coming from this point, so the wave front will be like this. But for the concave lens, they are moving away, then we can say we can extend them in the backside. They appears to move at this point and they appear that there's a point source from where the light wave is coming out. So ऐसे इसके wave front बनेंगे spherical, okay, like this. प्रिज्म है, अगर हमने देखा है कल प्रिज्म को सीखा है तो इस तरह से जा रहे हैं तो प्लेन ही है, तीनों पैरेलल है, यहाँ भी पैरेलल है और यहाँ भी पैरेलल है, बट एंगल चेंज हो रहा है प्लेन में। ये तो प्लेन वेव फ्रंट ही बनेगा। ठीक है। अब ये क्वेश्चन है देखो, वेव फ्रंट इंसिडेंट ऑन एन इंटरफेस between the media are shown in figure. Sketch the refracted wave front along with the values of the angle they subtend with the horizontal. तो देखो clearly mu1 and mu2 is mentioned, mu2 is much denser than the mu1, so refraction is taking place here। ठीक है। देखो सॉल्यूशन में इसका वेव फ्रंट के परपेंडिकुलर ही रे ट्रेवल करती है, मैंने बताया आपको। अगर इंसिडेंट रे ये इतना एंगल बना रहा है 45, तो ये परपेंडिकुलर हुआ तो ये भी कितना हुआ 45, विच मींस नॉर्मल से इंसिडेंट रे जो एंगल बना रही है 45, तो रिफ्लेक्टेड रे भी कितना बनाएगी 45। बट यहाँ पे रिफ्लेक्शन नहीं होगा, ये अंदर आएगा। ठीक है। सो बाई अप्लाइंग द स्नेल्स लॉ वी कैन फाइंड आउट द वैल्यू ऑफ आर, विच इज नथिंग बट साइन 30 डिग्री। ठीक है। विच मीन्स आर शुड बी 30 डिग्री। तो इस तरह से रिफ्लेक्टेड रे बनेगी और इसके परपेंडिकुलर आप क्या बना दोगे, वेव फ्रंट बना दोगे दिस। तो वेव फ्रंट नॉर्मल से 60 डिग्री पे बनेगा एंड हॉरिजॉन्टल से 30 डिग्री, रिफ्लेक्टेड रिफ्रैक्टेड वेव फ्रंट। नाउ द डॉपलर्स इफेक्ट। व्हाट इज डॉपलर इफेक्ट? सो वेन एवर यू वांट, देखो फॉर एन एग्जांपल, इफ द स्पीकर इज everything is well aware about these days, ठीक है, और bands that most of the time, this time of weddings, so most of you have heard about the bands and all. So whenever they approaches to us, it seems like the sound is increasing, and whenever they move from away from us, the sound is got decrease. Why it is happening so? So this phenomena would be explained by Doppler. Okay, and this phenomena itself is termed as Doppler effect. It is because of the movement, relative movement of source which is generating the waves and receiver, ठीक है, which is accepting the wave. The wave could be sound wave or light wave, for both. So it applies to anything that produces wave, sound or light, and it is nothing but the apparent change in the frequency due to motion of the source or receiver. So initially, if you will see, दिस इज द वेव फ्रंट फ्रॉम ए स्टेशनरी सोर्स, पॉइंट सोर्स है, तो परपेंडिकुलर वेव फ्रंट, क्योंकि लाइट रे और कोई भी वेव होगी वो इस तरह से ट्रेवल कर रही होगी, तो परपेंडिकुलर वेव फ्रंट बना रहा है। सॉरी, इन इन सब के क्या है, परपेंडिकुलर है। ठीक है। तो वेव फ्रंट यहाँ इस तरह से फॉर्म हो रही है। इसी तरह से अगर कोई स्टेशनरी स्टार है दैट विल generating light, it should be uniform and the wave front will be like this. if the star is not moving. So constant wavelength will be detected if the observer is at A and another observer is at B. So constant wavelength will be received because the star is not moving. Okay, uniformly generating the wave. But what if the point source is moving? So when the point source is moving, the backside, if you focus on the backside wavefronts, the source is making some distance. What is the relation between frequency and energy? देखो, energy is related to frequency like this, h nu. More is the frequency, more is the energy. ठीक है? And who has asked this? Harish. Okay, Harish. So E is equals to h nu, where h is the Planck constant, nu is the frequency of the source. तो जितनी ज्यादा फ्रीक्वेंसी होगी उतना ही हाईली एनर्जेटिक सोर्स होगा. ठीक है. तो देखो क्या हो रहा है कि ये पुलिस का सायरन है, सायरन ब्लो कर रहा है. ड्यू टू द ब्लो, ये वाला जो वेव फ्रंट बना, ये, और इससे पहले जो वेव फ्रंट बना था, अब उससे तो आगे ही चला गया ना ये सोर्स हमारा. तो नेक्स्ट वेव फ्रंट यहां से डेवलप होगा, बिल्कुल एग्जैक्ट मिड पॉइंट से डेवलप नहीं होगा. विच मीन्स देयर विल बी अ लैगिंग बिटवीन द सोर्सेज कमिंग आउट. ठीक है, बिटवीन द वेव फ्रंट्स. ठीक है. आप यहाँ पे भी देख सकते हैं, जब ये सोर्स मूव कर रहा होगा तो जो आगे वाले वेव फ्रंट है वो ज्यादा क्लोज बनेंगे, और पीछे वाले जो वेव फ्रंट है वो ज्यादा फार अवे पे बनेंगे. दे विल फॉर्म एट फार डिस्टेंसेस. इसीलिए the observer that is on the backside of the siren, or we can say that is away from the source, that will heard a sound which is less, and an observer or a receiver towards which the source is going on will receive a higher sound. Okay? Higher volume sound. तो स्मॉल वेवलेंथ हाई फ्रीक्वेंसी होता है. जितनी ज्यादा हाई फ्रीक्वेंसी उतनी कम वेवलेंथ. तो अब आप यहाँ पे देख सकते हो कि वेवलेंथ कितनी बन रही है, बहुत ज्यादा वेवलेंथ. इसलिए वेवलेंथ अगर ज्यादा है तो लो फ्रीक्वेंसी जोन होगी. लो फ्रीक्वेंसी मतलब वी आर नॉट एबल टू हर्ड इट. नाउ सेम हैपेंस टू द लाइट बिकॉज लाइट इज आल्सो अ वेव. So when a star is moving with certain velocity, observer B will receive higher frequency than observer A. ठीक है, because the separation between the star and the star is increasing. ठीक है. सो ए डिटेक्ट्स लॉन्गर वेवलेंथ. अब लॉन्गर वेवलेंथ मतलब जो कलर आएगा ना यहाँ से, व्हाइट लाइट प्रोड्यूस करते हैं कोई भी स्टार. लेकिन since A, this source is moving away from the A, so this observer at A will receive the longer wavelength light. And longer wavelength meaning you are moving towards red. So that is why we will see it as a red shift. And the observer B, which is nearer to the star and towards the star is moving or the source is moving, which receive a higher frequency signal or higher frequency wave, that will show a blue shift, because higher frequency is towards blue in this way. Vibgyor. So from red to violet, if you will move, you will have a high frequency. But if you move from red to wave again in terms of wavelength, so you will get lower wavelength. Okay. Now this is termed as the Doppler shift, which is nothing but delta nu by nu is equals to minus of v radial velocity divided by speed of light. ठीक है. Similarly, we can say it in terms of delta lambda. Delta lambda by lambda is nothing but equals to nu radial upon c, where v radial is the component of source velocity along the line joining the observer to the source relative to the observer. Suppose there is a source like this and it is moving in this direction, and we have an observer at this time here. So the line joining the observer, the point source S and E, along which the component of velocity, suppose this angle is theta. So this V cos theta, which is along the line joining the observer and the source, is termed out as V radial. Okay. V radial is considered positive when the source move away from the observer. अगर दूर जा रहा है इस तरह से, it's moving away from the observer, then it is considered positive, otherwise negative. देखो ये एक क्वेश्चन है. So the 6563 angstrom H alpha line emitted, which is this wavelength line emitted by hydrogen in a star, is found to be red shifted by 15 angstrom. Estimate the speed with which the star is receding from the earth. Because there is a red shift and we are observing it, which means the star is moving away from us. We are receiving the longer wavelength. So lambda is given to you as this. What is delta lambda? It's 15 angstrom. What is the formula of shift? Delta lambda by lambda. So V radial you will receive as 6.87 raised to the power 5 meter per second. Okay. तो इसीलिए हम ये थ्योरी भी कंक्लूड करते हैं दैट यूनिवर्स इज कांस्टेंट, यूनिवर्स इज एक्सपेंडिंग. ठीक है. Because we are already getting a red shift, so where the star are moving from away from us. So ultimately we can say that universe is expanding. Okay. Okay, this is it for today. If anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care.